Hey guys, today we're going to be working on solving square root equations and cube root equations. We've already learned how to do inverses, and the knowledge that we gained learning that is really going to help us out here because we already know how to deal with square roots and cube roots. So now we're just going to solve equations with them, which is something we're much more familiar with. So we're going to go over this example problem here first. I've got the steps written over here on the left side, kind of walking us through this. Of course, this is just one particular problem. Depending on where our terms are, we could have a couple additional steps in the simplifying part of this. So step number one is always to isolate the radical on one side of the equation. You can't deal with getting rid of it until it's alone. That's the same as it was for inverses. So here, the first thing I did was subtract 10 from both sides. These cancel out, and I'm left with 14 minus 10 is 4. Once the radical is by itself, and radical, by the way, is just a catch-all word for square root, cube root, and you can even have fourth root, fifth root, sixth. You can have any number you want. Radical just means all of them. But in this case, we're working with square roots, so they can mean the same thing. But once the radical is by itself, and this is the same no matter of which type of root we're working with, you are going to get rid of it. In the case of the square root, that means we're going to do the opposite, which is to square both sides of this equation. When you square something, just like with inverses, it just gets rid of this square root right here. 4 squared is 16, and again, the square root is just gone with the addition of that square. So we're left with 4x plus 52 equals 16. Once that is gone, you would solve it like you would any other equation like you first learned. I would need to get rid of this 52 by subtracting, which gives me negative 36 on the right side, sorry. And then I would divide by 4 to get my x by itself, and negative 36 divided by 4 is negative 9. Now, with square roots, the thing you have to be, with solving square root equations, the thing you really have to be careful about is that you can have something called extraneous solutions. We saw these when we did absolute value equations, and they're fake solutions. When we solve them, they appear like they're fine, and we get them the same way we would any other solution. But when you plug them back into the original equation, they don't work. We get that because when we take the square root of something, we already know that we have to deal with both positive and negative solutions to that square root. And the problem is the square root usually only applies to the positive solution of that. So for example, the square root of 4 can be both negative 2 and positive 2. But when we talk about the square root of 4, we usually just talk about the positive, which is, of course, 2. So if you had ended up with an equation with that, then negative 2 would be considered an extraneous solution because it wouldn't quite work. So we always have to take our values that we get. Sometimes we can get more than one. In this case, we only did get one. But whatever solutions you end up with, you have to plug it back into the original equation, which you can see me doing here, and go through simplifying. So 4 times negative 9 gave you negative 36 here. Negative 36 plus 52 gives us 16. This square root right here, by the way, should extend over that 16, my bad. And then the square root of 16, again, we're usually only working with the positive square root there, is 4, and 4 plus 10 is 14. And since 14 does equal 14, that means that's a real solution. If we had gotten something crazy like 0 equals 1, then that would tell us we're looking at an extraneous solution. So we're going to go ahead and work through this one now, following those same steps. Step number 1 is to get the radical by itself. Lucky for us, that's already the case. The only thing on this left side of the equation is the square root of 2x plus 7. So step number 1 is done. We can check that off. Once it's by itself, we need to square both sides of that equation to get rid of the square root. Now, you can write this in the second box if you're following along on my notes sheet, but I'm just going to do it up here so I don't have to rewrite it. I'm going to square both sides of this equation. Just like this. And of course, squaring it gets rid of the square root. So over here I have 2x plus 7. And for now, I'm not going to worry about extending the 2x plus 2 squared. We can extend it into a bigger quadratic equation like x squared plus 2x plus 1. Okay, that is possible, but we're not going to worry about that here. We're mostly worried about solving that square root equation. So once you've got it isolated, you can continue as you were before. Once you've gotten rid of that square root, now we can solve this as we usually do. So okay, so we're still going to be working with this left side, and we'll come back to this quadratic later, because when you do end up with quadratics in these square root equations, you do have to do something a little bit special. So we're continuing to look at this x, and this is the x that we want to get by itself. So our next step is going to be to get rid of that positive 7 right there. The opposite of plus 7 is, of course, to subtract 7. And just like when we did inverses, we can't go inside of those parentheses anymore. So these cancel out, and that minus 7 is just going to follow behind x plus 2 squared, like this. Next, you will divide both sides by 2, which will isolate the x. And when you divide the right side by 2, you're dividing this entire thing by 2. That is a very common mistake I see. That entire thing is being divided by 2. So we've got x equals x plus 2 squared minus 7, and that entire thing is being divided by 2. Now, if 7 was divisible by 2, you would want to simplify that, but 7 is, of course, an odd number, which means it's not divisible by 2, so we're just going to leave it like this. Now, on these questions where you end up with the quadratic, like we see here, of course, this doesn't say x equals negative 9, which means we've got one more step, actually. What we're going to do is, now that this x is by itself, we're also going to move it to this side, and we're going to work through solving a quadratic, just like we did back in Unit 5. When we solve a quadratic, we want it to say 0 equals blah, 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 right? The easiest way to do that is to just subtract x. Subtracting x means those are going to cancel out, and when there's nothing left, the number we use to represent nothing is 0. When you do this, just like with the 7, nothing can go inside of those parentheses, so this minus x is just going to be added to the end of this. So I'm kind of getting into my other box here, but it's okay. So this is the equation we're going to end up with. X plus 2 squared minus 7 all over 2 minus x. Now, of course, that doesn't look very much like quadratic equations we're used to, but if we're solving them by graphing, it doesn't matter. We can solve these by graphing by going to Desmos and graphing it. Make sure it looks exactly like the equation on the paper. That 2 should be at the bottom of the fraction of this entire thing right here, okay? That minus x is not in the fraction. Just a quick note, when you're typing fractions like this, you should always type the fraction bar first, because if you start typing x plus 2 squared minus 7, and then you type the fraction bar, it's just over this, it's just with the 7, and we don't want that. So you should always type that fraction bar first. To solve quadratics, one of the ways we learned was, of course, graphing, and we're looking for the x-intercepts. You are not looking for the vertex, you are not looking for the y-intercept. Desmos gives them to you, but they're not helping us in this situation. We only want the x-intercepts, and specifically, we want the x value, because that's what we care about. Here, that's -3 and +1. Those are my two solutions. I'm actually going to write those right here, just so I don't run out of too much space here. So x equals -3, and the other one was +1. I am going to go ahead and double check that after I finish writing this. +1? Yeah, +1. Okay, so we've got our two solutions, but again, we need to check for extraneous solutions because these can be fake. So we're going to plug them into our original equation. It doesn't matter which one you start with as long as you do both of them. Okay, you can have it that both are extraneous, only one of them are extraneous, or neither of them are. So you do have to check both. If both of them are extraneous, then we just say it's no solution and we're done. But again, I'm going back to this original equation. So we've got the square root of 2x, and I'm going to start with x equals -3. So 2 times -3, that's 2x. And then it was +7. And that +7 is under the radical as well. And it equaled x plus 2. Or, okay, whoops, my bad. It equaled x plus 2, and x is now -3. So we will simplify both sides of this equation. -3 plus 2 is -1. If you weren't sure about that, you could plug it in Desmos. For the left side of this equation, just like when we did, oops, did not mean to draw that. Just like when we did the quadratic formula, remember that we can get imaginary numbers using square roots, so we always want to type in what's under the square root separately. Again, you can use Desmos to help you with this. So in this case, we've got 2 times -3 plus 7, which is 1. So we've got the square root of 1 equals -1. And again, if you can't do square roots off the top of your head, that's what you have Desmos for. Square root of 1 is 1. Again, we are only working with that positive square root. It can also be -1, but we're only working with the positive number here. So we've got 1 equals -1. Now, of course, unless you're living in some weird land, 1 does not equal -1. So -3 is an extraneous solution. So I'm going to go over here and mark it out. Remember, you are taking notes, so don't scribble it out all the way because you want to be able to look back on this and see what you did. But do something, maybe you can just put another x beside it or something that's going to help you know that that ended up being an extraneous solution. So we will repeat that with the other x value, so x equals 1. So we've got the square root of 2 times 1 plus 7 equals 1 plus 2. 1 plus 2 is 3. And again, for that square root, you want to simplify underneath it first. 2 times 1 is 2, and 2 plus 7 is 9. Again, if you don't know square roots off the top of your head, that is okay, but that's what we have Desmos for. The square root of 9 is 3. And of course, 3 does equal 3. So that is a real solution. Now, here's what you need to be careful on. The solution is not the number you end up with down here. It's whatever you started with, okay? That is a big mistake that I see a lot, is that you get 3 equals 3 and you call it good, and you say, oh, the solution is x equals 3. A lot of times, x equals 3 will be an answer choice, and it is a wrong answer choice. The solution here is just x equals 1, because again, x equals -3 ended up being an extraneous solution. So x equals 1 is our only solution here. So again, square root functions can have 1, 2, or 0 solutions, depending on how many of them are extraneous. When you're solving them, sometimes you only end up with 1 in the first place, like for that first example that I walked us through, and sometimes you'll end up with 2. You'll never end up with none to start off with, of course, but you can end up with none if both of those solutions do end up being extraneous. I'm going to come back to some of these other examples later in the video, but if you do need to try these on your own. if I don't get back to them. But we're going to move on to some cube roots now. And then we'll go back and see some more examples. Okay, so cube roots are pretty much the exact same. The only difference is instead of squaring both sides of the equations, you're going to cube both sides of the equation. The other difference, sorry, there's two differences, not one difference. The other difference is that luckily cube roots can only ever have one solution. You can write the number 1 or you can spell it out, it doesn't matter. But they only ever have one solution because when we graph a quadratic equation, we can see that it's symmetrical on both sides, one side representing that positive solution and one side representing the negative solution. But if you were to, say, get rid of this and do, a cube root equation, there is only ever one number at every x value. So they can only ever have one solution. Again, square roots, with the square root equations, they can have multiple because we've got both sides, or quadratics can have multiple. So let's solve a cube root equation. I've also got an example up here, not as much because, again, it's very similar to what we just did, just now we have a cube root. For cube roots, you're still isolating that radical. That's always going to be the first step. So here I had to add 4 to both sides, which gave me this cube root equals 4. Then, just like before, we need to get rid of the cube root. So we cube both sides, which gets rid of the cube root, and we're left with just that 12x plus 28. 4 cubed is 64. And then we keep going from there. So divide by 12, or sorry, I skipped a step. Subtracting 28 gives me 36 on this side. Over here, dividing by 12, x equals 3. And again, they can only ever have one solution, which means we don't actually have to check for extraneous solutions with cube roots. We are safe from that. So let's work through a couple examples. I'm going to do, what do I feel like? I'm going to do this one down here. So again, step number 1, whether we're working with square roots or cube roots, is to isolate that radical. So I've got this 2 in front of the square root, or in front of the cube root, and that plus 1 right there. The plus 1 is always going to be the first thing to go. We're going to subtract 1 from both sides. Bring everything else down. So 2 cube root, and don't forget that 3 with the cube root, otherwise it's not a cube root anymore. 2 cube root of x plus 4, and of course 5 minus 1 equals 4. Next, you will divide both sides by 2. This 2 is still outside of that radical, so it needs to go before I can cube it. So divide by 2, which of course cancels those out, and 4 divided by 2 is 2. So we have the cube root of x plus 4. Once that radical is by itself, now we can get rid of it. To get rid of a cube root, I cube both sides. That gets rid of it, so I'm left with x plus 4 on this side. And again, if you don't know it off the top of your head, that's what you have your calculator for. You can do 2 cubed. Those parentheses are necessary for you. Sometimes it doesn't make a difference for the answer. In this case, it didn't. But if you had, say, -2 that you were cubing, -2 cubed versus -2 in parentheses cubed, Desmos is getting smarter. I swear, it used to be wrong. I think it still can be, so I would just be safe. Oops, that's the wrong thing. But anyways, 2 cubed is 8. Next, we'll need to subtract 4. 8 minus 4 is 4. Got a lot of double numbers today. Oops, my pen didn't stop writing. So we've got x equals 4. And again, we do not have to check for extraneous solutions with cube roots, so that's just the answer. So what I want you to do now is pause the video and try, let's try a little bit of an easier problem. Try this one to start off with. I'm going to go over this one and also this one. Those are the two that I would recommend you do next. Those ones are a little bit easier, and then we'll work through those. Okay, so over here, again, our first step is going to be to isolate the radical, whether it's a square root or cube root. So the first thing we're going to do is subtract 2 from both sides. So I've got the square root of x plus 8 equals 5 minus 2, which is 3. Next, you will square both sides of the equation. Now that that radical is gone, x plus 8 equals 3 squared, which is 9. I will then subtract 8 from both sides of this equation. And 9 minus 8 is 1. Finally, I will need to check to make sure that is not an extraneous solution. So I'm going to split my box in half here. And I've got the square root of x plus 8. X is now 1. That's the solution we found. And then we've got plus 2. And hopefully that equals 5. 1 plus 8 is 9. The square root of 9 is 3. So we got 3 plus 9. Or not 3 plus 9, 3 plus 2. And lucky for us, 3 plus 2 does in fact equal 5. So that's a correct solution. So x equals 1 is the solution, and the only solution. Let's go ahead and look at this one that I told you to do. So again, first step is to isolate that radical, and I know it's a little blurry, but that is a 3 right there, so this is a cube root that we're working with. To isolate the radical over here, I'm going to need to divide by 4. This is 4 times that cube root, and the opposite of multiply is, of course, divide. So we've got the cube root of x equals 3 over 4. Yes, we'll have a fraction. When you do end up with fractions, you should always check to make sure that they can't be simplified. You can do that easily doing Desmos, but this one is already simplified, so I didn't do anything there. Next, we need to get rid of this cube root, and to do that, we need to cube both sides. Oops, that's a weird looking parentheses, but I swear it's parentheses. You can cube fractions, no problem. You can cube fractions. Just make sure you're cubing the entire thing. These ones are a little bit harder to do in your head, for example, but again, that's what you have Desmos for. Yes, it will give you a big fraction, but it's okay. It's okay. This is the answer, okay? So 27 over 64. And of course, Desmos automatically simplifies it for us, so that can't be simplified any further. And that's just the answer. Again, for cube roots, I do not have to check for extraneous solutions. You can if you want, but no matter what, it's going to be a true solution, so you don't have to worry about it. Okay, I want you to do the rest of the problems on your own. Cube roots are a little bit easier, so if you are struggling, I would recommend you work with those first. I am going to go ahead and do one more example over here. I'm going to do this one. I would recommend you pause the video now and try it on your own before that though. So pause now, and then when you are ready or when you get stuck, you can resume the video. Okay, so we've got to get our radical by itself first. That's already the case here, which means I can jump straight into squaring both sides. So square this and square this. So we've got 42 minus 6x equals x minus 7 squared. Again, right now we're not working about expanding that and changing it to, x squared plus 2x minus 1 or whatever have you. We're just going to leave it with the parentheses for now. Next, I need to get rid of anything not with the x, so that 42 goes next. It's positive, so to get rid of it, remember when I'm adding and subtracting, my hope is that I end up with 0. So I'm going to subtract 42 from both sides. So we've got negative 6x, and here's where I see a big mistake. Don't forget that that 6 is negative, which equals x minus 7 squared. And again, that minus 42, it can't go inside those parentheses, so it's just going to be on the end. Next, I need to get the negative 6 away, and I'm going to divide by negative 6, not just 6, but negative 6. And again, I just divide this entire thing by negative 6. So x equals x minus 7 squared minus 42 all over negative 6. And finally, just like we did before, we're going to now move this x to the other side so that this becomes a quadratic that we're solving. So I'm not going to rewrite it, but you end up with 0 equals all of this, and that minus x is included. So now to actually solve that quadratic, we're going to graph it. So always type that fraction bar first, and you've got x minus, 7 squared minus 42 on top. Just going to verify. It's divided by negative 6, and then we have minus x. You'll look at your quadratic, looking for those x-intercepts of 1 and 7. So x equals 1. Oops, I did not write the equal sign. X equals 1 and x equals 7. They were both positive. I'm going to double check. Yes, they're both positive. So I'm not going to go through it, but your next step would be to check it to see if those are extraneous solutions, just like we did up here. I'm going to leave that for you. This is the hard part. So finish the rest of these problems. And then if you are in my class and you're watching this, when you're done, you do have an exit ticket, Unit 10, Daily Work 1. I believe it is just a couple questions, and then I'm asking you a little bit about those extraneous solutions. So finish these notes here, and then make sure you've done Unit 10, Daily Work 1. If you have any questions, let me know.